Hello everyone, I am Priyanka, Assistant Professor in the Department of Information Science and Engineering, NIT Institute of Technology. Today we are discussing the topic which is K nearest neighbor algorithm, which is one of the classification algorithm, comes under supervised learning algorithm, which we'll be using for the classification problems. Now we'll see how we are going to work on this. So before starting K nearest neighbor algorithm, I want to give an analogy of it, like how the K nearest neighbor works. So we take the example of any restaurants. So before going to any restaurant, we'll be taking the review from few peoples. So we'll be deciding on the menu based on the review given by the customers of that restaurant. Say suppose three people are telling that Italian is good in this restaurant and two people are saying Chinese is good at this restaurant. So then what we'll be doing, we are going to take which is the maximum voting given for the dish. So then we'll be choosing that one. So same here with the K nearest neighbor algorithm. So we are going to choose based on the nearest neighbor which is available as a data point. So we are going to put the data point into the classification. So we'll see what is it first. So the K nearest neighbor is a type of supervised learning algorithm, as I already said, and which is used for both regression classification, but mainly it will be used for the classification. And K nearest neighbor algorithm, which will be using the similarity index, so where we'll be checking for between the new data point and the already existing training data set. So we also call it as a non-parametric algorithm. Why? Because when we are giving the data, it will keep storing the data. So the training set will always be there, and it works based on the instance-based learning. That means if we give any new data point, then it is going to pick up the distances and it is going to decide which is the new data point it belongs to. So which is what is the best class for this new data point. So it will be not having any parameters earlier to classify this new data point. So that's why we call it as a non-parametric algorithm. And it is also called as a lazy learner algorithm because, as I already told you, when we give the data, it always keeps storing the data. It won't process immediately. So when we give the new data point, then only it starts processing and then it gives the classification. So now you see, so I have a different classifications available here, and I am also pointing a few K values here. This K value is going to define the new data point belongs to which class. Say suppose I have bees, I have chicken, I have cat, caterpillars are there, butterflies are there, many different classification is given. If any new data point is given, then that will be classified to the correct classification based on the K value. Here you see I have a cats and dog classification. That this is a new data point taken, and this new data point is taken and then classified into the cats based on the K value. And you see, why do we need this KNN algorithm? As we said, when we have got the new data point, we have to classify into a particular classification. So you see this category A and category B, and this is a new data point we have taken. So this is before the KNN and this is after the KNN. The algorithm, when we have given this input to this algorithm, it classified this new colored data point as a category A data point. So we'll see what is the algorithm, which algorithm and the algorithm how it works for the KNN classifier. Here also you see the cat is given and this is already available in the data set, and now it is based on the features that is taken, it is predicted the output as a cat. So now you see this is the algorithm how it works. So the step one is it select the K number of neighbors when it starts and then calculate the Euclidean distance of K number of neighbors. So when the new data point occurs, it calculates the distance between each instances available in the data set. And take the K nearest neighbor as per the calculated Euclidean distance. So after the Euclidean distance is calculated, next it is going to check for which is having the least distance between the new data point and the old data point. So that will be ranked higher. And among the K nearest neighbors, count the number of data points in each category. Say suppose if I classified k is equals to 3 and then it will select the first 3 which is classified as a value and then assign the new data point based on the voting. It assigns this new data point to the maximum voted classification. So you can see this. So now this is a gray data point. I have 3 different clusters, a light green color and orange color. So now this is a new data point. It has got 3 classifiers, 3 classification here, and it is going to calculate the distance between each data point available in the data set. Once it calculates, it is going to check which is having the minimum data. So then after having this minimum distance, so then it assigns the ranking. Now you see here 2.1, 2.4, 3.1, 4.5 like that. We have many different distances. So now it lists down all the distances in a ranked wise 1 to n in an ascending order, and then it is going to give the ranking to a. Now currently my value is 3. I am voting k is equals to 3, so that it takes the first 3 values. So now the first one is 2.1, second one is 2.4 and third one is 3.1. In this case, the class 0 has got the highest votings. So this green has got 2 votes, this dark green has got 1 vote and orange has got 1 vote. So since this light green color is having high votes, so then I am going to classify this new gray color data point to this light green color data point as a classification. So this is the same way we are doing. This is the first step. You are going to have the old data points and the new data point, calculate the distance and then assign the new data point to the category. So how to choose a k value? How to choose a k value when we are doing it? So initially what we do, we take the random numbers for k values. We always usually choose odd numbers, 1, 3, 5 like that. Instead of even numbers, we go with odd numbers. But initial thinking maybe if we choose higher the k value, say suppose my k value is 9, so that I will be having a better classification. No, it will not work like that. So sometimes it may lead to a wrong classification also. So how to choose the optimal value of k? How we are going to choose the optimal value of k? As we randomly, when we are doing the problem, we take minimum number of k values, just like 3, 5, 7 kind of things. So how we are going to select the optimal k value here? There are no predefined methods to find the k value. So we don't have any measurement to measure the k value. So we will be initializing some random k value and we will start computing with the data points. So I may take k is equals to 1, k is equals to 3, k is equals to 5 like that. So then I will be assigning the values and I will be checking which will be having the less error rates with that, and then I am going to find out when the data point which is having a less error rate, so that data point calculation or the k value will be taken as a actual k value to define the data set. Now you can see the example. I have a data set and split. So my points are this and features as given is there here, and then class is also assigned. So this is already existing and my test data is given as 2 different data points. Now the true class is also assigned here, which is 0 and 1. Now I need to check which is the exact k value that defines the whole data set is classified correctly. So now what I will be doing, I am going to check and I am going to assign the values for k is equals to 1, 3, 5, and then for each k I am going to check what is the error rate and what is the accuracy. So I am going to check here. So I have T1, which is for the case 1, I have considered k is equals to 1 value. Then my first data point, which is a 2.5 here, which is this one, 2.5. So k is equals to 1. So I am going to check what is the feature which is like nearest to this 2.5. When I check this, I can see this 2 is nearest, and that is k is equals to 1. So when I see this 2 and 2.5 are nearby and the class is y, the predicted class is here is 0 and here also it is 0. Then I say it is proper classification, and I say that 6.5 and here it is 6 and then it is classified as a 1, and here it is classified as 1. So then after that I need to check for the next closest data points. So initially I have checked with 2.5. So points x is equals to 3 and y is equals to 1 would predict that one class. We'll take the example. But exactly the true class is 0. Then we call it as a wrong prediction. And here when we take the example of point E here, point E compared to this 6.5, and the true class is 1, and here E point is classified as 1. So then you say this is the proper point, it is classified correctly, and this is wrongly predicted, and you are going to check the accuracy, which is total is 2 and 1 is correct. 1 by 2 is giving you 50% of accuracy. The error rate is always 1 minus misclassification rate. So 1 minus 0.5 is 0.5, that is your error. And in the next case, when we consider k is equals to 3 nearest neighbors, so exactly, so now we are going to check the 3 nearest neighbors in the data points. So what are the 3 nearest neighbors in this data points for 2.5? I can get 2, I can compare 3, I can compare 1. So these are the 3 nearest neighbors, and I have to check what are the classes available for these. And then I'm going to check for what is the majority class that is assigned. So when we take this C of 3, 1, B of 2, 0, A of 1, 0, the classes assigned to this are 1, 0, 0, and the majority voting is given for 0 classification. So in the second one, so the majority class is given for 1. So it is actually classification and predicted class is one on the same, so that I'll be getting 100% accuracy and the error rate is 0. Consider k is equals to 5 now, and I have nearest neighbor, which is a 5 data points. All 5 data points I have taken now. So which is a is equals to 0, b of 0, c of 1, d of 1, e of 1. Then I have taken the classification. It is giving me is 0, 0, 1, 1, 1 as the classes for these features. And when we take this, majority is 1, right? And then when we take the test point 2, the majority is also 1. Again, the actual class is predicted for 2.5 is 0, for 6.5 it is 1, but now for both it is showing 1. So the error rate will have to be calculated. Out of this, 1 is correct. So 1 by 2, you are going to calculate the accuracy. It is 50%. Again, you are going to calculate the error rate, which is a 0.5. Once we calculated this, we just putting in a table here, which is k is equals to 1, 3, 5, and the error rate for this is, for when k is equals to 1, error rate is 0.5. When k is equals to 3, error rate is 0. When k is equals to 5, error rate is 0.5. So when we compare this, when we have assigned the value k is equals to 3 has got the lower error rate. So then I'll be choosing my k value is equals to 3 in this case. So this is how I'm going to find out my k value, and this will be sometimes very computational cost will be higher when we have more number of data set to calculate error rate for each data point and then finalizing the k value. So usually we choose a random k values for this. And now, as I told you in this case, so we'll be using in the second step of our algorithm, we'll be calculating the distance between the new data point and the points which is already available in the data set. Now, we'll be using 3 different kind of distances, Euclidean distance, Manhattan distance, and then Hamming distance. When we are using continuous values, so we'll be using Euclidean distance and Manhattan distance to find out the k value, and then to find out the distance. And in the Hamming distance will be used when we are using the categorical variables. At that time, we'll be using the Hamming distance to find out the distance between the 2 instances. You can see the formula available here. For the Euclidean distance is a square root of summation of xi minus yi whole square values, and Manhattan is the summation of xi minus yi value. And the distance, Hamming distance, we know that if any 2 instances are same, that means we'll be giving the classification as 0, and if any 2 instances are different, then we'll be assigning the Hamming distance as 1. So we'll see how to work on this calculating distance and other things. Now you can take the example for continuous values, which is taken here is classification, which is versicolor, setosa and Vajnika. And for this we have some set of features and data values are available, say sepal length, sepal width, petal width, and we also have the class label. This is a classification done based on these features. So now I have 150 instances. If we take this example, if any new instances is given, so all this new instance has to compare with all these 150 instances to know the exact K value. So now we will see with a simple example. So we have a training data with iris flowers with 4 features: sepal length, sepal width, petal length and petal width. And the class is already defined, which is a training data. Now the new data has come up, new data point has come up. So what is the new data point values? 4.8 is the sepal length, sepal width is 3.1, petal length is 1.4, petal width is 0.2. Now I need to know to which class I have to assign this new data point. And here they already suggested use the KNN value, that K value is equals to 3 now. So now I have to find out the distance between this new data point and all the instances that is available in the table. So that is my first step. So now you see we are calculating the distance using the Euclidean distance formula. You can see how this is my data points, 4 features available, and this is the distance I need to calculate. This is the new data point. Now I am using this value to calculate the distance. So it is 5.1 minus 4.8 is 0.3 and then whole square, plus 3.5 minus 3.1 whole square, 1.4 minus 1.4 is 0, 0.2 minus 1.2 is 0. So apply square root and you will be getting the distances. And you need to do this for every single instances available in the training set. Once you do this, you can see I have a set of distances available for each instance, which is compared with the new data point. Once I get this, I have to assign a ranking. That is the second step. I have to assign a ranking to each distances based on the less distance which is having, because we will be choosing the nearest neighbor. So we have to assign the value which is having a lower distance. So when we have these values, we have to just go through the values. You can check here. So I'll be assigning the second instances which is having a less value, which is 0.141, and then I'll be choosing this data point which is 0.173. Then I can say this. So this will be chosen as the first K1, K value, K is equals to 1 here. This is the second ranking, which is K is equals to 2. And this is the next one will be chosen, this one, the third rank. And this will be a fourth rank, and this will be fifth rank. So I am assigning the values. I am assigning the ranking here. First rank, second rank, third rank, fourth rank, and fifth rank. Since my value, which is K is equals to 3, I am going to select the first 3 values. So first 3 values are this one, the first one, second one, and third one. In this, we are going to check what is the class that is assigned to this nearest neighbor. So now you see, I have assigned the ranking, which is first one, second one, and third one. Corresponding values that is given for this is Iris setosa, and Iris setosa. These are the classification values. The classification values is given. All the classification is related to the Iris setosa class only. Then I am going to finalize, because it is having a maximum voting, then I am classifying it as a Iris setosa. The new data point which I have got here is classified as Iris setosa, since all the values are given as Iris setosa. And now we'll see the another example with respect to same continuous values. So you take the example of this data set which is having a weight and height, and the class is given as underweight and normal. Two classes has been defined. This is a binary classification. Here you see I have a weight and I have a height values. Now I have a new data point is also given here. This is new instance x2 is equals to 57 kg, that is a weight, and height which is 117 centimeter is given. Now I have to classify whether it is underweight or it is a normal one. So now you see I have calculated the Euclidean distance for all the instances with a new data point. You can see this is a 57 is my new data point. So 57 is my new data point minus 51 whole square plus 170 is my new data point minus 167 whole square. So I'll be calculating the distances for each instances like this. Once I have calculated the distances, so I need to assign the ranking. So when you go for a ranking assignment, you can check here. So which is having a highest ranking, and it should have a lowest distance will be having a highest distance. Now this 1.41 is having the lowest distance, so I'll be considering this as my first instance. I'm considering here is equals to k is equals to 4 nearest neighbors. So first one 1.41, and second one is having this one 555, 170 is having a second lowest distance, and third one is this one where 57, 173, and this is also assigned a class as normal. And then the fourth one which is assigned as a this one 4.12 is assigned as a underweight classes. So after choosing the 4 nearest neighbors, then I have to go for which is having a maximum voting. Now you see here in this case I have a maximum voting for the class normal. So my new data point will be given as a normal data point. It will be classified as a normal weight. So like this we are going to calculate the k nearest neighbor, and now this is the advantages and disadvantages of k nearest neighbor. One is advantages of KNN is it is simple to implement, it is robust for the noisy training data, and it can be more effective for the training data. And the disadvantage will be it will be having a higher cost because it has to calculate the distance from each data point to all the instances that is available, so that it will be having a higher cost for the calculation of a distance. So that will be taking a bit time also, and this will be classified as a best classification algorithm, one of the best classification algorithm in the supervised learning. Thank you.